10th, 210. Off that pen alert. Watch out. Burp, burp. There we go. So today we are going to be converting the poopy equations, standard form, into the ones we like, Vertex. I don't So initially, what you're going to find is it's totally worth the effort. So it won't take long at all. Like at the first example, you'll go, "Oh yeah, it's totally worth it." And as we get sort of towards the middle, I believe that it's still fully worth it. The problems do become taxing and difficult enough that honestly, if a quadratic is just meant to kick your butt, it's going to kick your butt. So whether you convert it like you're going to learn today into Vertex, or you just do the negative b over 2a thing, it's going to kind of suck either way. But I think for the first like 70, 80% of what we're going to do the next few days, I think it's totally worth it. And I think you'll agree. I hope you agree. So the idea is, sorry, I just wanted to make sure that I hit record on there. The idea is we want to take this and make it look the way we like. You cannot deny, I mean, that the quiz yesterday had a front and a back. The front is just a more dreadful experience than the back. There is just no way around that. Like the front, you've got to do all the B2A, plugging it back in, denominators, all that kind of stuff, right? So ideally, what we're after here is can I make all the ones that I don't like look the way that I like? And that's yes, the answer is always yes. If you have a quadratic, you can always make it into vertex form. So here come the steps. This is how we do it. Uh, and by the way, f of x, I'm just going to try to be better at my job and start using that notation sort of interchangeably with y equals. Like you guys know, you've seen functions before. So like saying y equals and f of x equals same, right? Input, output. So in this case, what we're going to do first, I'm about to just walk you right through the steps. And these steps will morph, become more complex, but at their core, they generally stay the same. What I'm going to start by doing is leaving the quadratic term and the linear term here. And then I'm going to scoot the plus 13 off to the side. And just already right there, you might be thinking to yourself, like, I've seen this before. And I actually said the three words, didn't really mean to, but about 4 or 5 minutes ago, I said them out loud. What are we about to do when we leave that blank? Do you remember that little awkward void that we make and what we do with it? Yeah, man. Oh, say it again. Divide one of them by two and then square it. You're thinking of something called completing the square, and that is correct. Yes. So the idea here, and the reason for this is going to become, it's going to just whoop you upside the face when you see how obvious this is. But what we're trying to do is right here in this white blank, we're trying to make a square. Notice that my 13 is not in my blank. We always want to usher that number out. It just, I've tried it both ways. It makes it so much easier if you just get him out of the way first. Okay. So in the part that's underlined, I want to make a square. And you'll remember that the idea behind making a square is pretty much what Lex said. She had it pretty close. We're going to take this number right here, which is +8, and we're going to take half of it. What is that? So I'm going to write down +4. Not everybody writes that down. That's kind of a personal decision, but I find that it helps as a teacher, especially about 20 seconds from now. So I'm going to take that +4 and I'm going to square it. And what am I going to get? I'm going to get 16. Now, this is where there's several points at which this lesson really differentiates itself from what you've previously done. In the past, with completing the square, I would add 16 and then I would hop happily over to the other side of the equal sign and I would add 16 on the other side. That's not, this is not, we're not solving an equation. And this will bother you at first. It'll weird you out maybe once or twice or thrice, and then you'll just go, okay, I get it. I'm about to do something pretty weird. I'm going to turn right around and subtract 16. And you think about this for a second, and you'll hear me use this expression, erasing my footprints. And what I think about is if I add 16 to one side of an equation, I have totally screwed up the equation. I have thrown it all off kilter. It's no longer even the same math problem. But if I turn right around and on the same side of the equal sign, if I put a minus 16, a gain of 16 and a loss of 16 are a wash, and it's like I was never here. You say, well, then why do we do it? Well, we do it because of this. And you're going to see the answer just pop right out. It's the answer is going to be on the board here in about 12 or 13 seconds. I'm going to factor down the part that I have underlined, which, as you remember, is x plus 4 squared. And that's why it's so essential to get that void and to complete the square. Because already you go, hey, I know you. You're looking like that good stuff, the stuff I like, the vertex form. And then at the end, you got to do some little kitty math. What's 13 minus 16? And there, my friends, is your vertex form, just like that. It happens quickly. So my expectation on the assignment will be that you make graphs. I feel like I don't want to talk about that right now. I don't want to deal with the using the time, but you generally would be asked to make a graph. I just would ask you this, where's the vertex?
-4, negative.
Right. We will march through a couple more levels of difficulty, if you will, today. I want to give you one more simple one like this. This is as easy as they get. So let's do one more uber easy one like this. So let's do y equals x squared minus 2x plus 3. And I think where I'm at after one example is just, can you walk me through the steps? So here we go. What's step one?
I'm going to separate it.
Get that 3 out of there, right? Make a landing pad for completing the square. And I want to just say again, I have worked with people before who don't move the 3. They simply modify it to make it what they want. I just have found much more success with students if I just clear the landing zone completely. So I'm going to leave the x squared, the quadratic, and the linear stay put. The plus 3, I just kind of move them over an inch or two. And what I'm going for is in this white area that I've underlined, I'm going to complete the square. And the algorithm just doesn't change. Like it is what it is. What's half of minus 2?
-1.
Minus 1. And then I square it. And what do I get? I get
-1.
1. And so I'm going to add 1 here. How am I going to erase my footprints? I'm going to turn around and subtract 1. And don't say both sides. Be careful because like I'm doing I'm doing two different operations on the same side of the equal sign in an effort to make it like I was never there. And then I'm going to factor down the part that I have underlined, which is going to be x minus 1 squared. And then, of course, 3 minus 1 is just a nice, simple, rinky-dinky positive 2. Where's the vertex at with this one?
Or 1, 2.
There you go. So that's about bottom of the barrel. Can I clarify for you over there? Do you need clarification?
We were just looking at how you did number first one.
Let me go back real quick, okay? Which part did we part ways?
Um, so like plus 8x plus 16, how did that frame?
Because there's two answers to this question. Number one is the terrible, unprofessional answer. And if you don't want a factor, you can always just take. This is why I get frustrated when kids don't write that number down, that plus 4 that I wrote. So when you hear me say what's half of plus 8, and I say plus 4, I keep writing it down because you can just steal it and put it there. The more professional version of that answer is that I know, having spent time with you, that you know how to factor a quadratic trinomial like this. So if I laid this out for you back in September and said, hey, do me a favor and factor x squared plus 8x plus 16, you would build two shells. You've done this 1,000 times. You would put x's here because they have to multiply. Are you with me?
Yeah.
And then you would say they have to multiply to make a positive and add to make a positive. So I think they're both going to be positives. And then you'd say, what numbers multiply to make 16? Well, there's a bunch of numbers that make 16, but the only ones that will also conveniently add to make 8 are 4 and 4. And since it's the same, that explanation I just gave you is at the entire core of what we call completing the square. That number 16 was not an accident. Like it's very perfectly chosen to make that work. You got that?
Yep, thank you.
You're welcome. And if you ever want to avoid all of this rigmarole and just not even think about it, I cannot stress to you enough when you take half of the middle number and you say what it is, write it down. And then all you have to do is just yoink it, just whoop, and stick it in your parentheses. You don't have to think about it. Pretty slick. All right, we're going to up the difficulty level a little bit here. And it may not look like it to you, but we'll see. Some of you little wizards probably won't be even vexed by this at all. What changed?
You have three.
I do. Hold on a second. There's a three, right? So let me get you started on the steps here. To begin, we want to leave the quadratic term and the linear term here. That this will not change as far as like what consistently do I do first. You should always have the separation of your variable terms and your constant like this. What you want is to get this term, I'm going to point to him, to be alone. You want x squared to not have a number in front of it. So what could we do to make that happen? Good thinking. But what we're actually going to do, I appreciate that. What we're going to do is something we've done before. We're going to factor out a three, like a GCF kind of idea. Excellent input, but check this out. We're going to take y equals and we're going to pull three out of this and out of this. You see? So if I take the three and I stick it out front like this, what's left of 3x squared if I pull off his 3? X squared. What's left of minus 12x if I divvy him down by 3? Minus 4x. And note, I've still got my awkward void. That's intentional. And what we're going to do now is we're going to focus just on the awkward void. We're going to focus only on the parentheses. The 3 is going to be in a little bit of a timeout. The 7's in a little bit of a timeout. And we're just going to go laser focus on this right here. And this is our moment, right, boys? So what is half of minus 4? Minus 2. And what is minus 2 when you square it? 4. So we are going to add 4 here. And how do we offset adding 4? Exactly. We subtract 12 right at the end. Yes. Owen's looking at me like, yeah, I was a step ahead of you there, bro. That always happens. That's always kind of where the bomb drops. And that's the first time you really get to understand that what you think is a number is not really the same number. So I'm going to point to a number and ask you what it is. What is that? It's not a 4. What is it? It's a 12. Because when we think about what a number is, we can't just look at it kind of on the surface. And listen, I understand on the surface, like, come on, it's a freaking 4. I get that. But really, what is the overall value of that 4?
Well,
It is a 12. And the reason for that, I can prove it to you, is because if you take this 3 and you multiply it by this 4, last I checked, 3 and 4 are actually a net value of 12. So when I air quotes added 4, I was actually adding 12, which means that to offset it and erase my footprints, I have to turn around and subtract 12. You follow?
yeah.
Having said that, then we are one step away from our sweet, precious prize Vertex form, which is going to be y equals 3 times x minus 2 squared minus 5. Done. Let's go again. Where's the vertex on that one?
2
Nice. Okay, good, good, good. All right, let's go again. Round 4. This will be the final level of, I don't know, difficulty or complexity for today. I very consciously left fractions out of today's lesson, so tomorrow you will not be as lucky. Smooth sailing today. All right, what do we do first? Move that 11, but minus 11. Let's get that guy, kick him out. So we're going to have y equals negative 2x squared minus 12x, open space, minus 11. And honestly, as you come to see this next example and the one before, you start to realize we can technically combine steps 1 and 2. It's efficient, but I just didn't want to do it today. Next step. You want x squared to be just buck naked, just sitting there, nothing in front of him. So you always just say, there's whatever I need to get rid of. I'll just get rid of it. I'm not going to pay any mind to can anything else be divided by it. This is a very selfish process. Or a very like a direct, specific process. I want x squared alone. What do I do?
You have to pull the negative.
Yes, you do. So we're going to pull out -2. And do remember that when you pull it out, you're not pulling it out from the 11, right? You're only pulling it out from the first two terms. So if we pull out -2, what's left of -2x squared?
Square.
What's left of -12x?
Hence.
What was the first thing you said? Yes, but what's in front of it? No, it's a plus 6x. And remember, when you pull a negative out, dividing by a negative has the same effect as multiplying by a negative, right? So that's why we have to change the sign of that 6x. So plus 6x is in the middle. And then I'm still back here, just going to kind of copy down this guy. And then the algorithm kicks in. What's half of plus 6?
Plus 3.
Plus 3, square it. What do you get? So I'm going to add 9. And again, you're not going to fall for it this time. Last time you all very robotically, dutifully said the obvious wrong answer. This time you're not going to fall for it. What are we going to do at the very back? No,
Oh, no.
Minus 18.
we are not going to minus 18. What is the net result of this times this? What, pray tell, does that equal? That is a net result of -18. How will I offset a -18? I will go to the very back and I will add 18. That yellow arrow is going to get you through the next quiz. Or if you don't respect it, it's going to be the reason you don't get through the next quiz. The yellow arrow reveals the true identity of your square completer. You might put a 5 there, and then it's like, holy smokes, like I actually have something completely different. It's nuts. So y equals what? -2 times
X plus 3.
squared.
Plus 7.
Done. Okay. How long should one of these take for you to do by yourself? Should we say a minute tops? I'm going to give you one now, and I want you to try it all by yourself. Can you do it? Vigo says no. How about I'll do one more with you? Does that sound good? Okay, good. F of x equals -x squared minus 10x minus 31. And again, like I said, you will start combining these first two steps into one. I just don't want to do it to you today. So I'm going to leave my -x squared and my minus 10x here, and I'm going to scoot the minus 31 off to the back. What do I need to pull out of the first two terms? Just the negative. Well, it's not unimportant, but it's not really, it's not hard. So we have f of x equals, pull the negative. Respect what you just did. Don't waggle your finger at the math gods like these things don't matter. What will my first term be in here? What will my second term be? Plus 10x. Good. Remember, change those signs when you pull a negative. -1 like this, negative anything, switch all your signs, right? Okay. Follow the steps now. What's half of plus 10? What's plus 5 squared? So we are going to, quote unquote, add 25. Oops, I forgot to copy down that guy. How will I erase the footprints of that red plus 25? Nope.
Plus 25.
I'm going to add another 25. You're like, what? And I would ask you again, as I will every time, what is the answer to that yellow arrow multiplication problem? What is it? It's -25.
Oh.
And what is the offsetter of a -25? Adding 25 more. So again, what you see is not what you're actually doing. That number in front of the parentheses is going to be the killer. So we have f of x equals the negative of x plus 5 squared minus 6. Vertex at -5, -6. Now I'm going to ask you to do one all by yourself. And I'd like to give you no more than a minute. Even that feels like too much, but what the heck? Here you go. So when you're done, just read me an answer and I'll write them all down. I've done this with you before. I'm going to write them all down in red and then we will make fun of the people that get it wrong. Not really. I'm just kidding, kind of, maybe. Here we go. Y equals negative x squared plus 8x minus 15. Ready, set, go. And I'll pause the video just so there's not an awkward 1-minute silence here. Now I'm ready. Go. Thank you. Other answers? So that's kind of what I mean by doing the 2 steps at once. I'm sure you would have figured that out, but kind of moving the annoying number and also GCFing or whatevering, that should all be done. Could all be done at once. So the magic number in this case, half of -8 is -4. -4 when you square it is 16. So we're going to add 16 here. And how are we going to erase that plus 16? By adding another 16, because we know what he really is, right? And so then we wind up, say again? I think I resumed it already. I did. I was on top of it. So we wind up with y equals the negative of x minus 4 squared plus 1. Okay. Did you guys get that right? Most of us? Let's go again. This time, same drill. I want you to do it all by yourself. Do you want the harder one and then the easier one, or the easier and then the harder? Okay, harder one first. Good. Harder one first. Here we go. And it's not even really hard. It's just a little extra challenging. Boom.
Parentheses x plus 1 squared plus 10.
-4 quantity x plus 1 squared plus 10, did you say?
Yeah.
Okay, thanks, dude. Others?
Plus 10 or plus 7.
Okay, so you got -4 x plus 1 squared plus 7. Okay. Others?
I got the same starting but plus 5.
Okay. The purpose behind this is always that we either celebrate our success and go, yeah, I think I got this, or we don't pout. We look at what's about to happen and we say, where did I go wrong? That's the goal, right? We're not out to, try to make ourselves feel dumb. Just get stronger, better. So I'm going to start by taking, there it is. He just had his moment over there. So I'm going to take the -4 and I'm going to pull it out of the x squared and I'm going to change the -8x to a plus and also divide it by 4, leave a space and then move the 6. And it's very robotic, right? So then I'm going to take, oh, there it was. That was it right there. Then I'm going to take half of +2, which is +1, and I'm going to square it. Just having that number up there is a nice little friendly reminder. So I'm going to add 1. And how do I offset that red number? I'm going to add 4 more. Again, why? Because over and over again, this yellow arrow will tell you the truth. The yellow arrow is a -4 times a +1, the net result of which is -4, and there's always a way to make something go away. The way to make a -4 go away is by adding 4, which leads us then to the answer, which is f of x equals -4 times x plus 1 squared plus 6 plus 4 plus 10. So we had our victor right out of the gate. Uno más. Last one. This one, this one will be a nice little change of pace. You'll see that the negative in front makes a big difference, right? Uh, I think we saw that on that one. I would bet the vast majority of wrong answers came from getting goobered by the negative. I'm not even going to pause it this time because you guys are so fast. I'll just keep it going. So like, if your answer doesn't look like this, then something obviously has gone catastrophically wrong. You got one? I'm ready.
Well, it's squared, but plus two.
Okay, thank you. Another?
I have the same thing, but minus 4 to 7.
Okay. We got two flavors on the board. Is there a third? Mhm.
Answer's not.
You're taking yours, you're withdrawing your submission. Are you just saying that because of those guys? Okay. Anyone else have the top one or can I kill it? Okay. So it sounds like you're committed to the middle one, maybe. All right, let's go through it and then I'll give you your assignment. Try to get done what I need to get done. So here we go. We're going to pull out the two while simultaneously showing 94 to the side. And then when you pull the two out of the first two terms, you're left with x squared and minus 14x, leaving that nice little void for the algorithm, the repetitive algorithm. Half of minus 14 is minus 7, which when squared gives you 49. So we are going to add 49. And how will I offset that? I will subtract 98. It just can't stress enough to you to reveal the identity of this number. You must multiply by the number that you pulled out. Then you go, you're really a 98. And so that's where that comes from. So uh, I'm liking the -4 that I'm seeing at the end. So this is going to be y equals 2 times x minus 7 squared minus 4. And again, just in case you missed it, this -7 up here, I don't know if I can actually, oh, I did. I was able to grab it. Do you see how it just comes into the parentheses right here? So I just was trying to show you guys over there. So kind of neat. Any questions? All right. I'm going to hand out number 32 and I'm going to try to motor through a little bit more of this. You'll get this done probably with time to spare. FYI.
Can't write on my.